Hello everyone, I hope you all are well and making progress in life. Here is Priyanshu and welcome to the Infinity Mind. So today I will be solving the problem LeetCode number 1 to sum. So the problem statement says that given an array of integers nums and an integer target, return indices of the two numbers such that they add up to the target. You may assume that each input would have exactly one solution and you may not use the same element twice. You can return the answer in any order. Alright, so the problem statement just says that we are given an input as array and a target, and we just have to find the pair such that it sums up to the target. Alright, so as in the example one we can see that the nums array is given and target is given 9, so we have to find just the pair that sums up to the target. So we can see that here the pair 2 comma 7 sums up to the target, that is 9. 2 plus 7 is equals to 9. So we can see this is one of the pair, and in the problem statement here it is written that you may assume that each input would have exactly one solution. So we can be sure that the pair we have got is only the one pair, and we don't need to check further now. So we will just return this 2 comma 7. All right, so in the example 2 also 3 comma 2 comma 4 is given and target 6 is given. So we can see that element, the pair 2 comma 4 sums up to 6, so we will return 2 comma 4. All right, so here we have to return indices of the two numbers. So we have to return indexes, not the number, we will return indexes. All right, so similarly we understood the question now. So how we will solve the question? So the first brute force approach which comes into my mind is just to go and check all the pairs. We can just go and check all the pairs, but this will take around, for checking all the pairs we will go from I is equals to 0 to the end, and j will start from I plus 1 to the end. Alright, now this will take big O of n square time complexity. Alright, this is one of the brute force approach. Now in the problem, follow-up says that can you come up with an algorithm that is less than big O of n square time complexity. So the another approach is we can use hash maps. We can just use hash maps also. I will explain the method, how this hash map method works. And the third approach we can think of is using two pointers, that is one I and j. And if first of all we have to make sure the array is sorted, and we will sort that array. So this will, for sorting it will take n log n time complexity, and now we will keep two pointers for I at the first, j at the last. And if I plus j, no, and nums of I plus nums of j equals to the target, we will say okay, we have found, and we will return at that point. Else if the target is, if the sum of I and j numbers are less than the target, it means we have to increase the sum. So we will increase I in that case forward by 1, and similarly if the sum is less than the target, we will just decrease j to reduce the sum. Alright, so this was the second approach. This will take around n log n time complexity for sorting, and moving I and j, this will take big O of n. So at max, at in the worst case, we can say that our time complexity will be big O of n. Now what I think is I am implementing here hash map, or we will use an ordered map or map approach, because using that unordered map or map approach, hash map approach, this will just take big O of n time complexity, but also big O of n space complexity also for using that map. So I will explain you through an example. So here we have array 2, 7, 11 and 15. So we have the array 2, 7, 11 and 15, if I'm not wrong. 2, 7, 11, 15. What we will do, we are standing here, right? And our target is 9. So our target is 9. All right, this is our target. Now this is our target. So we are here, our eye pointer is here. Now we have to, and we will make we will take a hash map or an ordered map. So we are here, element is 2 and target is 9. So what do we need? 2 plus something element which will equal to 9. So what will be this? This will be nothing but 9 minus 2, that is 7. So if we find 7 in this array, we can say that yes, we have found our pair that will sum up to the target. So we, standing at that element, we will check in the hash map that is there any 7 in the hash map. So right now hash map is empty. We will say that no, there is no 7 in this array. Okay, no problem, we will move. So moving here, but before moving, we will store this 2 here. So the key will be the element, and the pair, this pair, oh sorry, value, this will be index. So this index is 0. Now we will store this before moving. Now we have moved, now we are here 7. Now what another element we want? Second element. So 7 is there, 7 plus something we want which can equal to 9. So this something is equal to 9 and 7, that is 2. So we will check in this hash map or this map that if 2 exist in this map. Yes, if 2 exist in this map, so we can be sure that we have seen 2 all before. So yes, 2 is here. Now we will say yes, we have found 2 and we have found such pairs. So in this case we will return, we will just simply return according to the problem. We have to return vector of indices. Now we will simply return I where we are standing, and this index 2, value of 2. All right, so this will be 0. So we'll just return here 1 comma 0. I is 1 here, and this value of index of 2 is 0. So we'll just return 1 comma 0. So your answer is also 0 comma 1, because here it is written that, and you may not use the same element twice. You can return the answer in any order. So we can either we return 0 comma 1 or 1 comma 0, that doesn't matter. All right, so this way we will use map for storing what we have, what element we have got till now, and reaching, standing at every element, we will just check what another element we want, so that we can sum up to 9. So this way we will solve it. And yes, we know that there is exactly one solution, so we will break here. If we have found any element, we don't need to go further, because there is exactly one solution. All right, so if I implement this, first of all I will declare the size of the nums array. This will be nums dot size, and we are using map. So what kind of map should I use? So either I can use a simple map, ordered map, or I can use an ordered map also. But we all know ordered map, unordered map I am using. So here keys will be the element and value will be the indexes. So this is map. Now we will iterate from the starting to the to each element, and at every step, first of all, what I said, that if we are standing here, we will check what next element we want, so that 2 can add up to that element and give us as a result 9. So this will be target minus the current element. So let me name this as more. What more, what how much, what could be the next element? So I'm just naming it as more. So this will be more is equals to target minus the current element, that is nums of I, and we will go and find in the map dot find what this more is not is equals to map dot end. So if we have find that pair of element, we will just say that we exactly one solution is there, we will return from here only in any order. So we can return I, and in the map I will check what's the index of that more element. So I will return here. Else if we didn't find any element, we will just move, and yes, before moving I will store the current element and its index. So current element is nums of I, and its index and its value or index is I. All right, and at last we are exactly there is one solution only, but for writing good code and violating not violating the rules, we should return empty vector if it doesn't return anything. So I think it should work now, and if I run the sample test cases, so it's giving some error. mp.find more is not equal to mp.end. So if mp is declared an ordered map and mp.find, okay, more, so is not equal to mp.end, what error value of type iterator, what kind of error it is giving? If suppose the second half, second second element I have to found, second partner of that element I have to find. So I will find in the map dot find more, and if it finds me, it will give is not equal to mp dot end. Here is it is giving not contextually convertible to bool, and the more checking the constraints. So what kind of error it is giving me? mp unordered map more is equals to target minus nums of I, and if mp dot find more, I have to find this element in this map, and this is not equal to mp dot end, and I will return if I am missing anything while declaring the map. This is mp. Okay, I have just missed this space here, just a silly mistake. I've just given a space here. Now if I, yes, all the test cases are passed now. So this was all about this problem. So before ending, I will tell you the time and space complexity. So time complexity will be nothing but we are using a single for loop and we are using a map. So we are using unordered map. So for finding, it will just take big of 1. If we were using ordered map, then in the average case it will be using big of n, big of log n. All right, so here we are using an ordered map, but yes, in the extreme worst case, it can go and just for finding it can take big of n. So this whole for loop, and inside this finding map, it can take, in the extreme worst case, it will take big of n square, but in the average and best case, an ordered map will work fine. and that extreme worst case is very rare. So we can say time complexity is just we are using a single for loop and finding its in average case is big of 1. So time complexity will be big of n, and space complexity we are using map also, so it will take some space, so this will be big of n. So now this is all about this problem. I hope you understood, and thanks for watching. Till then, keep learning and keep upgrading yourself. See you in the next video.